Right, good morning class. At this point in this lesson we're going to go through our cycle test. And this was grade 10 cycle, grade 10 cycle test 2. This is now of course term 2, 2022, St. Susie Girls High School. Right. So this was your cycle test. It was worth 50 marks. You're on for 1 hour. So let's do the memo to this quickly. This is how you're supposed to have gotten 50 marks. Okay. So in question 1, let's make it smaller. So in question 1 we are told, use your diagram below. Or the diagram below shows a kite ABCD. BD is 16, so you put 16 here. It's going to be 16 centimeters. AB, which is 10, is already marked. C1 is 28, which is already marked. Okay, I did that so that I can bring this a bit lower. Right. So the question says, determine with reason the length of BM. So BM, we know that one diagonal or the longer diagonal bisect the other. It's not the diagonals, some of you wrote diagonals bisect each other. That's not the case. If the diagonals is bisecting each other, then both diagonals are cut in half. But this is not the case yet, it's a kite. So this is 1.1.1. The length of BM is equal to 8 centimeters, and the reason there for your second mark is one diagonal bisect the other in a kite. You can't say properties of a kite. Okay? That is 1.1.1. 1.1.2. So I'm going to put 8 here. So 1.1.2, the question says the length of AM. Now to calculate AM, I need to use, well, how are you going to calculate AM? By using Pythagoras. Not so. However, in Pythagoras, I need a right angle triangle. Not so, a right angle. However, we know that is a right angle. So since it's not on the diagram, hello? So this is not on the diagram. Okay? The 90 degrees is not on the diagram. So what do? We have to state. Not so. So we say that AMB, that angle is 90 degrees. Why? Because your diagonals are perpendicular in a kite. There are 3 such quadrilaterals where that is the case. One is the kite, the other one is a rhombus, and a square. Those are the 3 quadrilaterals where that is the case. Okay. So now I got the right angle triangle. So now I can say that 10 squared is equal to 8 squared plus AM squared. And your reason here, of course, is Pythagoras with angle AMB equals 90 degrees. Alright. So that works out to be 36, so AM works out to be 6 centimeters. So again, I put that on the diagram. Okay. I put that on the diagram so I can remove this here. I would like to keep the diagram in focus. The next question. So in the next question we are asked to calculate the size of D2. So if we're looking at D2 is this angle here. Okay? So we got 90, we got 26 here. Am I missing something? Okay, D2. So this angle is 28. This is 28. That is 90, so I can work out D2. Not so. You all agree this is 90 here. This is 28. Why is C2 28? It's also a property of a kite, not so. So C2 is equal to 28 degrees. Why? Because one diagonal bisect the vertex angle. One diagonal bisect the vertex angle. We know that is 90. We can either say vertically opposite, so we state its reason on this angular reading, or we can say that CMD is equal to 90 degrees. Same reason as before. The diagonals perpendicular in a kite. Diagonals are perpendicular in a kite. Alright, so D2 is equal to 180 minus 90 degrees minus 28. The reason there is sum of triangles, and this is triangle CMD. Okay, so that works out to be 62 degrees. Not so? 62 degrees. And in the next question we are asked to prove that CMB and triangle CMD is congruent. To prove congruency is going to be one of four cases: side, 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 angle, side, right hand, hypotenuse, side, or angle, angle, side. Those are the four cases for congruency. Okay? So how do we always start with congruency? With naming the triangle. So we say in triangle CMB and triangle CMD. Okay. So what can we say? CM is a common side. Right? What else can we say? We know that is 90 and this is 90. Not so? So we're going to say that BMC is equal to CMD, which is equal to 90. We spoke about that already, so we say proven. It's perpendicular. Okay? So we got that side, 90. So we know also that BM is equal to MD. Why? Because I want diagonal or proven. So we use that already. Not so? We say proven. So therefore, triangle CMB is congruent to triangle CMD. Why? I used side, angle, side. Now if you had said that CB is equal to CD, because two pairs of adjacent sides are equal in a kite, then your case of congruency would have been R. So you use your right hand, which is the 90, the hypotenuse and the side. Okay. So or you could have used side BM with MD, MC which is common, and BC with CD. Then I would have used side, side, side. So in actual fact, you could have used any of the cases, or any of the four cases of congruency could have been used in this case here. Does it make sense? Because we have so much information on this diagram, or on those two triangles, that you could have concluded any of the four cases of congruency there, and you should have gotten the full 4 marks there. Let's look at the next question, question 2. In question 2, we are told that consider triangle EFG. Below H is the point on EF such that, so here we are told that if H is equal to HE. J is a point on FG. J is a point on FG such that HIGJ forms a parallelogram. So that is parallel, that is parallel, that is equal. That angles are equal there. And diagonals, no diagonals would have been bisecting each other there, but there isn't of that thing. So just that at the back of our mind. Okay. We are told that FG is equal to 14 millimeters then. So FG, this is 14, yeah? 14 millimeters. Then we are told that EI is 5 millimeters. EI is 5 millimeters. Then you are told that angle E is 72, which is already marked. Then if H is 54 degrees, the diagram below is not drawn to scale. Okay? The first question says, determine with reason the size of angle G. So I'm going to make this a little bigger. Okay, so that is your 14. That's there. Okay. So the question says the size of angle G. So people, we know that these lines are parallel. Not so. So angle G is going to be the same as 54 degrees. Why? Corresponding. But are those lines given parallel initially? No. So we have to state it. So we're going to say that HJ is parallel to IG. Why is that the case? Because two pairs of opposite sides parallel in parallelogram. Okay, there's one more thing. Then we're saying now that angle G is equal to 54 degrees. Why? Because the corresponding angles are equal, with HJ being parallel to IG. Is 54 degrees. Okay, let's go to the next question. The next one says the length of HI. So we're looking at the length of HI. We know that the midpoint theorem is going to come into play. Not so. So if that is equal to that, as given the other diagram, and this length here is parallel to that length, then HI will be half of GF. Not so. Is that not the case? Yes. So is those two lines parallel? Yes. So in 2.1.2, we know that HI is parallel to FG. JG. Just put JG. So I know it's coming from this part, from GJ, sorry. And since it's one line, the whole line has to be parallel. Not so? So why is those two lines parallel? Because two pairs of opposite sides parallel in parallelogram. Okay. Then, so that's that. Then we know that each H is equal to FH. Why? That was given to us. Why am I saying this? I'm qualifying why am I going to use that. Which theorem am I going to use here? The midpoint theorem. I'm qualifying why I'm using that rule. Why? Because if we have a triangle with that equal and that equal, then we know by default that lines are parallel and that length is double the other length. Not so. That is the midpoint theorem. And the other one says if that is equal and that is parallel, then we know that this length is equal to that length and that is double that here. Not so? And this is the converse of the midpoint theorem. Remember we made notes on this? And this is where we're going to do the application again. Okay. So we say, therefore, HI is going to be half of FG, which is 40. Why? Because it's the converse of the midpoint here. You can't just write midpoint here. Converse of midpoint here. Okay, so which gives you an answer? 7. Okay. 2.3, the length of EG. EG. So EG, this whole length here, not so. But firstly, I know that IG, 2.1.3. I know that IG is equal to 5. Why is IG equal to 5? The converse of the midpoint theorem. The converse of the midpoint theorem. Therefore, EG is equal to 10 units. Or 10 meters worth. 10 meters in this case. Right, you guys understand? Right. The next one says prove that the triangle is an isosceles triangle. We'll draw this up here. Take that out. So they want you to prove that triangle EFG. So EFG, the big triangle, is an isosceles triangle. Alright. So under what condition would this be an isosceles triangle? It's either that the two base angles are equal or the two lengths are equal. Not so. So in other words, I need to work out, if you're going to go with the two angles being equal, I need to work out the angle of F. Not so. But if we're looking at F, okay? If we're looking at F, then I can go with this triangle here. Not so. So angle F is equal to 180 minus 72 minus 54 degrees. Why? The sum of triangles, and this is triangle EFG. EFG. Okay, so angle F works out to be what? 44. 54. So since angle F is 54, therefore triangle EFG is an isosceles triangle. Why? Because the base angles are equal. So angle F is equal to angle G, which is 54. I have to write that in as well. Okay, but since that is the case, you can now say that triangle EFG is an isosceles triangle because the base angles are equal. What's wrong, Michael? Okay, that now brings us to the end of question 2. Let's look at question 3. It says use a calculator to determine the value of the following correct to 2 decimal places. Okay, so the first one, that people is going to be sine of 67 squared plus 1. Put that in the calculator. Open brackets. Sine of 67 squared plus 1. Give an answer 1,85. It says correct to 2 decimal places. That's going to be 1,85. The next one is tan. It's going to be 3 tan 17 degrees over cos 16 degrees. That gives us an answer of 0,94. 0,95. Okay. You all okay with that? Okay, and with the next question. Sec. Now sec is 1 over cos, not so. So it's 1 over cos 78 times cot is 1 over tan, 23 degrees. That can simply be written as 1 over cos 78 times 1 over tan 23 is 11,33. Is that correct? Right. 3.2. In question 3.2, the question says calculate the magnitude. Now the magnitude is the size of theta correct to one decimal place where theta is an element of 0 to 90, which means to say it's an acute angle for each of the following. So what do we do first? Arctan. Can I divide by 3 first? No. So arctan of 1 is 45. So 3 theta is equal to 45 degrees. So theta works out to be 15. Everyone okay with that? People, there was somebody in either in this class or in the other class whose calculator was not in degrees. So always make sure your calculator is in degrees. There must be a D on top. Okay. People, the next one, can I take arc sine immediately? No. I first need to isolate the trig ratio, not so. So how do I do that? Divide by 8 both sides first. Okay. So if I divide by 8, so you got sine theta equals a quarter. So arc sine of a quarter, which shift sine or arc sine of a quarter gives us 14, 4, 8 or 14,5. How many decimal places is this? Did it specify? 1. Yes, so it's going to be 14, 4, 8. No? So 1 decimal place would be 14,5 actually. That's the answer that you give. No? So it says 1 decimal place. The next one. Here we got 3 cosec theta is equal, minus 2 is equal to 0. So first isolate the trigonometric ratio. So it will be 3 sec theta equals 2. So I divide by 3 both sides. So sec theta is equal to 2/3. But sec is the reciprocal of cos. So it's 1 over cos theta is equal to 2/3. So you take its reciprocal on the one side is equal to the reciprocal on the other. Sec. So no solution here. So that's given outside the range. Was that the correct answer? Oh yes, okay. So you put that in your calculator. Arc cos of 3 over 2 is your math error. So you should have said no solution. Okay. So no theta value will actually satisfy that given equation. Right, number 3. In question 3, we are given a triangle. The angle C equal to 90 degrees. Express each of the following in terms of A, B, and C. So sine of beta. So if it says beta, or angle B, sorry, I must go with that angle. So sine is opposite over hypotenuse, will be over C. You all agree with that? Tan of A, there's angle A. Tan is opposite, which is A, over adjacent, which is B. Cos of B is adjacent, again this angle, adjacent of hypotenuse, so it's going to be A over C. Cot of B, also this angle here, cot is the reciprocal of tan. Tan is opposite of adjacent. A cot is adjacent over opposite. So it's A over. Right. Let's carry on with the next question. 3.5. In question 3.5, question 3.5, they want to know what is sine of A. Sine is opposite, so it's A over hypotenuse, which is C, times cos of B, which is adjacent, which is A over hypotenuse, which is C, so it's A squared over C squared. Alright. You all okay with that? Let's carry on with our lives. Right, question 4. In question 4 we are given point P, which is negative root 21 and 2. Is a point of the Cartesian plane such that OP creates an angle of theta with a positive x-axis. As I indicated before, that will always be the case, that the angle will always be open from this arm, from the positive x-axis. Alright, let's see what's the question. So question 1 says, okay, so firstly, this is an x and a y. So that's going to be negative root 21, y is 2. So how do we calculate OP? By using Pythagoras. So OP squared is equal to 2 squared plus negative root 21 squared, which is 4 plus 21, which is 25. The square root thereof is going to give you 5. People, for the hypotenuse or your radius, that length will never be negative. Okay. So the hypotenuse is never negative. And then when I take the square root of 25, it's supposed to have been plus minus. But not in this case, because why? It's your hypotenuse. So the length of OP is, this is question 4.1.1, is 5. Alright. 4.1.2 says hence write down the value of sine theta. So sine theta, what does sine stand for? Opposite over hypotenuse. So it's 2 over 1. Okay. In 4.2, question 4.2, it says determine the length of AC. So we got 12, we got 48. Yes, AC. What is AC to the relative to the angle? It's your hypotenuse. What do we have? We have our adjacent. So which trigonometric function am I going to use in order to calculate AC? Cos. So it's going to become cos of 48 degrees equal to adjacent, which is 12, over hypotenuse, which is AC. So naturally that's over 1, I cross multiply. So AC, cos of 48 degrees is equal to 12. Divide by cos 48 both sides. That cancels, so AC is equal to, on my calculator, I put 12 over cos 48, gives us an angle of, a length of 17,93. So they didn't specify here, so I must use 2 decimal places. It's 17,93. Alright. 4.2.2. Of course, that angle here is the sum of angles in the triangle. So angle A is equal to 180 minus 90 minus 48. Give you an angle of 43 degrees. That's sum of triangles. Okay? Being triangle ABC. Alright. Next question, 4.3. In 4.3, it says determine the value of x in the diagram below. So x is your angle. So here we have an adjacent and we have opposite. So which trigonometric function is opposite and adjacent? Tan. So we say tan of x is equal to your opposite, which is 5,44. over adjacent, which is 2 comma 5. So x is equal to arctan. So shift 10 of 5 comma 44 over 2 comma 54. I'll give you an answer of 64 comma 97 degrees. Okay, it says one. If you go one decimal place, no problem. It would have been 65 degrees. Not so. No, the angle they normally give you one decimal place. But this was a giveaway bonus question also. Yes, many got this right. I almost thought you guys don't know what to do with the extra 2 marks in the exam. So the angle marked y is equal to. So we have to first set up an equation for the relationship between these angles here. So that's an exterior angle. So what can we say? 2x minus 40 equals y plus x plus 10. Why? Because the reason here is the exterior angle of triangle. That's the exterior angle if it's not marked. Did we have to write the reason and all of this down here? No. You're just going to select the letter there. I'm just writing here to say what theorem I'm using. They want you to write what y is equal to. So we must say make y the subject of the formula. So angle y, or y is equal to 2x minus 40 minus y minus 10, which gives you x minus 50, which makes the answer D. Okay. Alright, it was a fairly decent paper, nice paper. No? Most of you scored well. Surprised me. Yeah? Latita. Thank you, my Taba and Lisa Kanya. Right. That gives us basically 9 minutes left of this lesson. So I'll stop the video at this point. Or you want me to do the class test one time? Okay, I'm going to just pause this and hand out the class test. Alright, so what we're going to do is we just delete this page. So basically the class test told us a total different story. Alright, class test 2. So here, listen. So that other test was set by the other teacher. And this was the test I set for last year. It's grade 10 cycle test. This was either in the cycle test or the tuning test. I think it was a cycle test. If I'm not mistaken. Okay. So, let's do this quickly. So the question says, using a calculator, you determine the value of each of the following. So here we are given your tan of alpha. So it will be tan alpha, which is 316,4 minus 212,6. And this must be squared. Okay. You just put your class test. This class test 3 term 2. Oh, I feel like I forgot to square my. But let's see. So it's going to be tan, open brackets, tan 316.4 minus 212.6 squared. That's the answer I marked on. Okay, so that's going to give you 16, 57. 587. Right, the next one. Cos of 2 times alpha. So it's going to be 316, 4. When you put that in the calculator, so it will be cos 2 times 316.4. That's going to give you 0,05. Okay. The next one is sine beta, which is 212,6 over 2 minus the square root of 5 and 6 over 13 cos of alpha, which is 316.4 minus 1. Now when you punch this in the calculator, you will have sine 212.6 over 2. Oops. 212.6 over 2 minus square root of. Now you see this is a mixed fraction here. When you punch that in the calculator, you press shift and your fraction button. You all see that? It will be 5 and 6 over 30 cos 316.4. It's over. Now you see where that minus 1, and minus 1 is not in the bracket, so you close the bracket. Minus 1. It's going to give you negative 0,76. You got that and I marked you wrong? I marked you right? What? Oh, you're telling me you had it but you didn't write it down. That's not my fault. Oh, right. You change your mind, you lose your luck. Not so? Yes, you're right. Look at 1.4. People, what was the... Now you see here we got cosec. So that is going to be... What is the reciprocal of cosec? 1 over sine. Not so? So it's going to be 2 times 1 over sine. So it's 2 over sine. Beta, what is the size of beta? 212, no? No. 212,6. Many of you brought the 2 also down. Remember that is cosec. So that's going to be 2 times 1 over sine beta. Okay. So that would simply be 2 over sine 212.6 gives us negative 3,71. The next one, using a calculator, solve for x. So what do we do here? You arc sine, you get 30 degrees. Not so. The next one, I must first divide by 4. So sine x plus 20 equals. So on your calculator, you got 3,953 over 4, which is 3,953. 3,953 over 4,000. Then you got arc sine. Okay. You shift sine. That answer, last answer calculated, is 81,2. And then x is equal to, you minus 20 from that, you get 61,2 degrees. Alright, you guys got it? The next one. The next question, you see this, I could have just punch in the calculator there. So it's going to be tan 2x is equal to. So we say sine 41.3 close bracket plus sine 153.6 gives you 1,104. The number of course carries on. Now we say arc tan of that. Again, we use the answer button. The answer is the last answer calculated on the calculator. So shift tan of that answer is going to give you 47,86. So 85. divided by 2. Again, the answer divided by 2 gives us 23,92. Okay? You all okay with that?
Yes.
Let's look at question 3. In question 3, it says find the value of y without the use of a calculator. Solving or showing or working. Use a suitable special angle diagram to solve the given equation. Alright, so the special angles that we're referring to here are these triangles. For those of you who are seeing it for the first time, that is 30, so it's 1, 2, root 3. That is 60 there. It's going to be 1, 1, root 2. It's 45 degrees. And this is not a triangle, but it works for what we're looking at. There's 1, 1, 0, and 0. Okay, so we go y, tan, sine of 60. Sine is opposite over hypotenuse, so it's root 3 over 2, equals cos of 40, that is not one of the special angles, times sec. Sec is the reciprocal of cos. So it's 1 over cos 40 times cos of 30. Cos of 30 degrees, again adjacent of hypotenuse, that's going to be root 3 over 2, all over tan of 45, tan is 1 over opposite of adjacent, so it's 1 over 1. Cos of 0 is 0, the adjacent of hypotenuse is 1 over 1. So I'm just going to tidy up a bit, so that cancels. So in other words, I have y times root 3 over 2 is equal to root 3 over 2. Can you see that? So y is equal to? If I get y on its own, what do I need to do? Divide both sides by root 3 over 2. Not so. So y is equal to 1. Alright, the last question here. It says in the diagram, we are told that STR and triangle YTR are isosceles triangles. But ST equals SR and YT equals YR. Okay? If angle YTR is equal to 36 degrees and SRY, this angle here is 24 degrees. The question says you must calculate the size of TSR, which is this angle here. Okay. So where do we start? We need this here. If we can set up an equation for sum of triangles, I've done the job. Not so. But however, this angle, which is y RT, that angle here is going to be 36 degrees. Why? Angles opposite equal sides. Okay. So this whole angle here is the same as this angle, not so. So you say STR is equal to SRT, which is equal to 24 plus 36, which is 60 degrees. Why? Because angles opposite equal sides. So now remember that's now 60. So I can now say that angle S is equal to 180 minus 60 minus 60, which is 60 degrees. Why? Because it's sum of triangles. This triangle is STR. You guys understand? Any confusion? Alright. Please collect the portfolios again. Who's collecting?
Morning, sir.
Who collects the portfolios? Okay. People enjoy the rest of your day. Good morning, class. Salam.
Das ist so.